In this session, we will discuss the second part of 2G CDMA. This is the concluding session as far as the CDMA discussion is concerned. In our part 1, we have discussed what is CDMA, what are the characteristics of orthogonal codes used in code division multiple access, and the basic concept of CDMA. Now we will further continue our discussion on CDMA. Here we will discuss about CDMA IS 95 model. So the model is IS 95, Interim Standard 95 model. This is the basic and popular model as far as the second generation CDMA technology is concerned. In CDMA, that is code division multiple access, the entire bandwidth is shared among different users by assigning unique codes. Here what I mean to say is the entire available bandwidth of the telecom service provider is used by all the users, but they are differentiated with different codes. The available bandwidth is available for all the active users for all the time of their conversation or duration of the conversation. But the only differentiating factor is code. Frequency is same, the bandwidth is same, the time may be as long as they speak, but they are differentiated with reference to code. Each user will have his own code. For example, in CDMA IS 95 standard, entire bandwidth of 1.25 megahertz is shared by various channels for users using unique 64 Walsh codes. So the bandwidth of CDMA IS 95 model is 1.25 megahertz. If you can compare this with our bandwidth of the channel carrier of GSM, it is only 0.2 megahertz. So it is 60 times more than the bandwidth of the GSM carrier. And each user will have one unique code. There are 64 unique codes known as Walsh codes. Indirectly, we can interpret that in a base station area, at any given time, a maximum of 64 users can make use of the network with different Walsh codes. In CDMA, the entire bandwidth is used by all the users all the time, and each have their unique codes to recover the data. So the same thing here told, entire bandwidth is available for all the users all the time, but each user will have his own unique code for transmission and recovering the data at the receiving end. The system works based on spread spectrum concept. So the CDMA system works based on the concept known as spread spectrum concept. What is this concept? We will try to understand in further discussion. Before this, we will try to understand the main problem associated with radio frequency transmission. The problem is like this: frequency dependent fading can wipe out narrowband signals for the duration of the interference. Frequency dependent fading can wipe out narrowband signals for the duration. Due to interference, the narrowband signals are wiped out due to interference. So that is the main issue with the radio frequency transmission. So then what is the solution? The solution is to spread the narrowband signal into broadband by special code, and this is known as spread spectrum concept. So here we spread the narrowband signal into wider band with the help of a code, and this is known as spread spectrum concept. Then we will discuss about the spread spectrum principle. This is the diagrammatic representation of spread spectrum principle. So we will simultaneously look into the information on spread spectrum principle. So this is the signal to be transmitted to the receiving end. First, this narrowband signal is multiplied with the spreading code and modulated into a wide band. Here you can see the bandwidth is increased vis-a-vis the original narrowband signal. Then this signal, this wideband modulated with spreading code multiplication, is sent to the receiving end. During its travel from the transmitter to the receiver, so the wideband signal is affected by noise shown in this red color peak and interference shown in the blue color. Then at the demodulator, by using this spreading code, the spreading code what we use at the transmitting end, the same spreading code is used for demultiplexing or multiplying this signal. This signal consists of wanted green color wideband signal as well as the noise and also the interference. So then the demodulated signal will look like this, because while demodulating, the code used can convert the wideband wanted signal into peak, and there is no change as far as the noise and interference are concerned. This noise and this interference. So this peak can be easily detected by the receiver. This is the basic concept on which this spread spectrum principle works. Let us go through the contents of the slide. The narrowband signal in the green color is modulated, multiplied with spreading code at the transmitting end. The output of the transmitter is a wideband spread signal shown in green color. This one. This is the modulated signal at the transmitting end. The wideband signal during its travel from the transmitter to the receiver, noise in red color and interference, what I have shown in blue color, are superimposed on the signal. While traveling from the transmitting end to the receiving end, noise and interference are superimposed. At the receiving end, the received signal with noise and interference, with noise and interference are demodulated with the same spreading code or multiplied with the same spreading code used at the transmitting end. In this process, there is no change in the amplitude of interference and noise. So there is no change as far as the interference amplitude and noise amplitude is concerned. However, due to despreading, the original narrowband signal peak in green color can easily be retrieved due to the peak amplitude of the original wanted signal with reference to unwanted noise and interference. Okay, this peak of wanted signal can easily be detected. This is the basic concept of spread spectrum principle. Then we will discuss about GSM versus CDMA. GSM we have exhaustively studied, and CDMA in nutshell we have studied, because our main intention is to thoroughly study the GSM. And at the same time, we will try to compare the GSM and CDMA together. GSM, which stands for Global System for Mobile Communication, and CDMA, which stands for Code Division Multiple Access, are two dominant technologies for mobile communication. The two technologies differ in the way the calls and data travel over the mobile phone networks. So there are two dominant technologies in the 2G mobile communication is concerned. One is the GSM and the other one is the CDMA. These are the two dominant technologies. On comparing both the technologies, GSM has some limitations as far as the call quality is concerned, but still has more flexibility and easy implementation relative to the CDMA technology. So both got some merits and demerits. So as far as the call quality is concerned, CDMA is better. As far as the flexibility and implementation is concerned, GSM is better. CDMA is a little bit complicated. The major differences between the two lies in terms of technology they use, the differences in technology, security factors, global reach, and speeds. So the differences between the two dominant technologies, that is GSM and CDMA, lies in terms of the technology, the security aspect, the global reach, and the data transfer speeds. We will try to understand these four aspects in detail in our subsequent slides. So first we will take the comparison of GSM versus CDMA as far as the technology is concerned. The CDMA is based on spread spectrum technology, what we have studied, which makes the optimal use of available bandwidth. So it uses the entire available bandwidth. That is one positive aspect as far as the CDMA is concerned. It allows each user to transmit over the entire frequency spectrum all the time. The entire spectrum of the telecom service provider, like 1.25 megahertz in CDMA IS95, is available for all the users. That means a broad frequency carrier is available for all the users. On the other hand, GSM operates on the wedge spectrum called a carrier. So in GSM, we divide the frequency band into narrow band carriers of 200 kilohertz or zero point 0.2 megahertz. So the carrier width is very less in GSM. So that's why it is known as wedge spectrum technology. This carrier is divided into number of time slots, as we have seen, into 8 time slots, and each user is assigned a different time slot so that until the ongoing call is finished, no other subscriber can have access to this carrier time slot. So each user is given a time slot in a carrier till the conversation is over by a user who occupies a time slot in a carrier. That time slot in that carrier cannot be allotted to any other person. This is as far as the GSM technology is concerned. And further, GSM uses both time division multiple access and frequency division multiple access together for user and cell separation. So as far as GSM is concerned, as we have thoroughly discussed, first the available frequency band is divided into n number of frequency or n number of frequencies or n number of carriers with a narrow band of 200 kilohertz. And further, this carrier is divided in time domain into 8 time slots, 8 slot, and each user is given one time slot. This is the technology. So that is spectrum technology. This is wedge spectrum technology. Then we will proceed with further discussion of the difference between GSM and CDMA. Security aspect, which is better as far as security aspect is concerned. More security is provided in CDMA technology as compared to the GSM technology, as encryption is inbuilt in the CDMA. So CDMA, the inherent property of CDMA technology is to provide encryption. So therefore it is more secure when compared to GSM. A unique code is provided to each and every user, and all the conversation between the two users are encoded, and therefore ensuring a greater level of security for CDMA users. So because they are encoded, their transmission and reception depends upon the coding. So greater level of security is offered by CDMA, but it got certain riders. The signal cannot be detected easily in CDMA. So because of the complexity of encoding, decoding, and all these things, the detection of signal is not easy in CDMA as compared to the GSM, which are concentrated in the narrow bandwidth. So GSM narrow bandwidth only we are using, like 200 kilohertz. Therefore, the CDMA phone calls are more secure than the GSM calls. But in terms of encryption, the GSM technology has to be upgraded so as to make it to operate more securely. So to improve the security, so GSM has to be upgraded to make it to operate more securely. As far as security aspect is concerned, CDMA is better, but it got its own merits as well as demerits also. Then we will take another aspect, that is global reach. GSM is in use over 80% of the world's mobile networks, telecom service providers. 80% of the telecom service providers, they adopt GSM in over 210 countries in the world as compared to CDMA. CDMA is limited to less number of countries. CDMA is almost exclusively used in the United States and some parts of Canada and Japan. So CDMA is exclusively used in the US, Canada and Japan. As the European Union permits GSM use and CDMA is not supported in Europe. So GSM CDMA is not supported in Europe. European countries, they adopt GSM technology. In North America, especially in rural areas, more coverage is offered by CDMA as compared to GSM. In North America, so if you can take, so the CDMA provides more coverage in rural areas when compared to GSM. So CDMA is extensively used in North America, particularly with a specific reference to rural areas. As GSM is an international standard, so GSM is an international standard, so it is better to use GSM for international roaming. Since GSM is an international standard, it is better to use GSM for facilitating international roaming. Then we will discuss about the user base. GSM user base is 76% as compared to CDMA, which has a user base of 24%. So GSM is more widely used by not only in terms of the countries adopting GSM, 80% countries they adopt GSM, 20% only CDMA. But as far as the user base is concerned, 76% of users they use GSM and 24% of the users in 2G they use CDMA technology. Then we will look into the comparison between GSM and CDMA with reference to data rate or the speed that it can support. CDMA has faster data rate as compared to GSM, as EVDO technique, that is evolution for data optimization, data transfer technology is used in CDMA. For data transmission, CDMA uses EVDO technology, evolution data optimization. So it supports more data speed when compared to GSM. And it can support up to speeds up to 2 megabits per second. But EVDO ready mobile phones are required to use this technology. So just like that, you cannot use EVDO technique. A mobile phone which is compatible for EVDO is required to utilize this technology and to achieve speeds up to 2 megabits per second. This is considerably high speed in those days of second generation mobile communication. Of course, we cannot compare this with 3G, 4G and the 5G technology in the offing. But in the days of 2G, 2 Mbps is considered to be a high speed as far as mobile communication is concerned. GSM uses edge principle or edge technology, which stands for enhanced data rates for GSM evolution, which we have discussed separately as GPRS and edge. So it supports a maximum download speed of 384 kbps, which is slower when compared to CDMA EVDO technology. So here it is 2 Mbps, here it is only 0.384 megabits per second, or rather to say 384 kilobits per second. For browsing the web, to watch videos and to download music, CDMA is better choice when compared to GSM. Why? Because CDMA can provide you speeds up to 2 Mbps, whereas GSM can support only 384 kbps speeds. That's why for browsing experience, watching videos, downloading the music, so it is better to use the CDMA technology. CDMA is known to cover more area with fewer towers. Another beauty of CDMA is that it covers more area with less number of base transceiver stations. So this is an added advantage as far as the telecom service provider is concerned, as far as the investment for the TSPs is concerned. So that is the advantage. Both got its own merits and demerits. So GSM is extensively used and international roaming is easy as far as GSM is concerned. CDMA is restricted to only 20% of the countries, but it got quality wise, it got certain advantages. But technology wise, it is a little bit complicated when compared to GSM. GSM is a easy technology. It got good global reach. More countries they have adopted GSM than compared to CDMA. Okay, this is about CDMA second part. Here one important note is there. The architecture of CDMA is similar to GSM. So the architecture of CDMA is same as GSM. So we have the mobile user and the base station, we have BSC, we have MSC, and we have gateway MSC and connected to PSTN. For data, we have SGSN and GGSN connected to core data networks. It is same. That's why we have not separately discussed about the architecture of CDMA. Both are same. You can say CDMA MSC, CDMA SGSN, or same GSM and GSN can be used and GGSN can be used. The MSC may be different and sometimes the gateway MSC may be different. So, but for that, so the concept is same, the architecture is same. So BTS, BSC, MSC, gateway MSC, and data side SGSN and GGSN. So this is what I wanted to discuss about the CDMA in this second part. So this is the link to my YouTube channel, that is youtube.com/c/Hariva Prasad Damarla. So far I have uploaded more than 40 videos on telecom technologies pertaining to electronic switching systems and mobile communication. Please give a like if you like my YouTube channel as an encouragement, and also share with other colleagues and friends. Thank you very much.